Hey everyone, let's talk about chirality, one of the coolest concepts in organic chemistry. Now hold up your hands and look at them. They're mirror images, right? But try putting a right hand into a left hand glove. Doesn't work. Your hands are chiral. They're non-superimposed mirror images of one another. That's exactly what enantiomers are. They are molecules that are mirror images of one another and they cannot be overlapped, just like your hands cannot swap gloves. Now let's look at this problem. It says draw the enantiomers of 1,3-dibromobutane, label them R and S. They're very kind to put the asterisk exactly where they want us to draw the molecule. And they're kind of giving us a chiral center. Now, what is a chiral center? A chiral center is a place where you have four different groups. So if you look at this molecule, let's number it first. Carbon 1, carbon 2, carbon 3, carbon 4. This carbon 3 is attached to a hydrogen, a methyl, a bromine, and a CH2CH2Br. If we draw this molecule, it's going to look like this. You're going to have that central carbon, which was carbon 3. It's going to attach to the bromine. It's going to attach to the CH3. It's going to attach to the CH2Br, and it's going to attach to the hydrogen. How are we able to take this molecule and configure it to the R and S configuration as it states above? It says draw them as R and S. So we have to first understand what R and what S is. So the way to do this is, let's erase this first. We have to understand that R is equal to right / clockwise, and S is going to be left counterclockwise. So R is right, S is left. Now, how do we know what's going left, what's going right? So we first have to assign the groups based on their priority. Think of a sports team. The larger the group, the higher the priority. So our biggest group here is going to be the bromine. So it's going to be first priority. Then it's going to be this CH2CH2Br. And then it's going to be this methyl, the CH3. And the last one's going to be that hydrogen. Now let's draw out how it's going to look like. So remember, R is clockwise, S is left, and counterclockwise. Let's take this. Let's move this to the side. So we're going to draw that carbon. We're going to draw the bromine. We're going to draw that CH2Br group. We're going to draw the methyl. The methyl is going to be outside the plane, and the lowest priority, which is going to be the hydrogen, is going to be behind the plane because it's on the bench, it's behind or behind the field. Now we draw our little arrow. We're going from our number one priority, which is the bromine, then the CH2CH2Br, and then the methyl. We just draw a circle. Connect 1, 2, and 3. 1, 2, 3. And that's going to be the R configuration. Now, how do you draw the S? Same idea. So we're going to take that carbon, same carbon, put the bromine on the other side, put the CH2Br group, put the methyl on this side, which is coming out of the plane, and take that hydrogen, which is on the bench, which is within the plane, and we draw a circle based on the priorities. So bromine is the highest, then the methyl, then the CH2CH2 bromine, and then this methyl group. Connect 1, 2, and 3. That's going to be the S configuration. That's R, that's S configuration. That's how we're able to draw it. If you have any more questions, Gen Chem, OChem, Math, and much more, book a session with me and we'll work through all your problems.